like, share, and subscribe to my YouTube channel. Thank you for your support. For this video today, we are going to enter the discussion of the exercises for chapter 3, okay, in the pure mathematics 1. So these first few questions are from the Coursebook. Okay, so let's take a look at the question 1. Given that there are three coordinates which are P16, Q-21, and R3-2, show that triangle PQR is a right angular isosceles triangle and calculate the area of the triangle. Okay, sorry about that. So for this question, you need to draw a diagram for you easier to visualize and provide your workings over here. Okay, so this diagram on the left I have drawn earlier. Okay, you can draw it by yourself if you want. So to show that PQR is an isosceles triangle, okay, so we have two workings that you need to show that. First, right angular triangle, and it is also isosceles. Okay, ask yourself, what is the properties of an isosceles triangle? Okay, any two sides which have equal length. Okay, second, what is right angle triangle? Okay, it means that a triangle must has a right angle of 90 degree. Okay, so to do so, I need to find the each distance between the coordinates. Okay, between the two ends of the coordinates. So for me, I will. Okay, as you can see that these coordinates are not accurate. Sorry about that. Okay, so the purpose of this drawing is to easier to approximate their approximate positions. Okay, so I need to take the distance of the PQ by using the Pythagoras theorem, which is the difference of x square plus the square of the difference of y, sum it up all and take the square root. Okay, so for PQ I have 1. Okay, 1 minus -2. Okay, carry out the same procedure to the y coordinate as well. Alright, so you have square root of 34 for PQ. Okay, so let's take a look at the PR. Okay, what is PR? PR, just using the same procedure, which is using the distance formula from the Pythagoras theorem. So you have 1 minus 3 square plus 6 minus and minus 2 square. Okay, so you have 2 square root of 17. Alright, for the QR, you have negative 2 minus 3 square plus 1 minus 2. So QR is 34. Alright, so based on these three length calculations, so what you can observe that PQ, any two lengths which have equal length. Okay, two lengths have equal length. Okay, two sides are equal in length. So you can see that PQ equals to QR. Okay, this is the first you have shown that PQR is an isosceles triangle, but you haven't shown PQR is a right angle triangle. Okay, so what are you going to do? You see, when will you use a Pythagoras theorem? Okay, when you are dealing with the right angular triangle. Okay, so as you know that here is your A, B, and C. So what are their relationships? Just Pythagoras theorem, which is A squared plus B squared equals to C. Okay, So just carry out the same way. So since PQ is equal to QR, that leads to this angle might be the right angle. But how to prove it? Okay, so you need to prove from left to right. So you have PQ and QR. Alright, so you have to PQ square plus QR square as your left hand side. Right hand side is the PR square. Okay, so what is the PR square? Which is 68. Okay, so now you have to prove that the square root of PQ plus square root of QR to get 68. Okay, so you have 34 square root of 34 square. Okay, yeah, so you will get 68 for the left hand side as well. So yeah, it's shown. Okay, so you have successfully shown that this PQR, triangle PQR, is a right angle triangle by using the Pythagoras theorem, and isosceles triangle by identified any two sides which are equal in length. Alright, so I need to create a page, okay, since there's insufficient space for me to perform the next working. The next working, which is calculate the area of the triangle. Okay, how to calculate the area of the triangle? It's very simple. You can use the either you can use the Heron's formula, okay, or you can use the shoelace formula. Okay. I'm so sorry about previously I haven't explained this clearly. Okay, so let me explain to you to this area of the plane figures polygon. So actually this is the area of the triangle using the shoelace method. Okay, so why is it called shoelace method? Because you need to say there's a cross. Okay, when you tie a shoelace. Okay, so you can see each of it has a cross over here, each occasions. Alright, so for me, I will carry out shoelace area of the figures by using the shoelace method. So which is A equals to, you have three coordinates, right? Half of the modulus of, we need to start from P 1 6 Q -2 1. Okay, where these are x coordinates and these are y coordinates, and as well as R 3 -2, and you need to return to P. Okay, because you want to calculate the area of the polygon in the closed triangle. Okay, P to Q, Q to R, and also you need to return back to P. Okay, that makes sense. So how to use the shoelace method? Okay, sum of the positive, which is this shoelace, 1 times 1, 2 times -2 times -2, and 3 times 6. Okay, I need to check back first. Yeah, correct. So we need to say the modulus of bracket 1 times 1, which is 1, -2 times -2, +4, 3 times 6, 18. Okay, minus of this sum of these three products. Okay, so 6 times -2, -12, 1 times 3, which is 3, -2 times 1, which is -2. Okay, so next you calculate the evaluate the values inside the modulus first, just before you modulus it. So we'll get 34. Okay, since you've calculated +34, therefore just divide 34 by 2 enough. to get the final answer, 17 units squared, as the area of the triangle PQR. Alright, that's the end of the discussion for the first question. Okay, let's move on to the next question, which is the question 2. So this question is also from the Coursebook. Alright, the distance between the 2 points P, A, -1 and Q, -5A is 4 square root of 5. Find the two possible values of A. Okay, so what does this mean? It means that the value of A is not only 1, but 2. Okay, why it's 2? We will explain this right now and also in further. Okay, check it out. Distance between 2 points. Use the formula. And you can see that there's another side of the distance between the 2 points in the exact form, which consists of roots. Okay, consists of the radical square root. So you need to carry out the distance between the 2 points, which is the square root of the difference between the x coordinates square plus difference between the y coordinates square, and then take the square root after the sum of the squares. Okay, so you need to a minus -5 square plus -1 minus a squared, that equals to 4 square root of 5. Okay, so I need to simplify this first before I take the square at both sides. So you have a plus 5 bracket square and a plus 1. Okay, so how to get a plus 1? As you can see inside the function, inside the term, you can factorize as 1 plus a, correct? So following the indices rule, you need to distribute the power into here and here, since this and these are the products. Okay, so as negative square, you will get positive. Yeah, makes sense. And still there's a square and 4 square root of 5. So now it's time for you to take the square of both sides. Okay, this square you may cancel out, this square you cancel out, but following the indices rule, you need to square the 4 simultaneously. Okay, so what is the square of 4, which is 16? 16 times 5, 80. At the same time, you may expand these two terms. So you may for the first term, you may expand as a square plus 10a plus 25. Meanwhile, which is a square plus 2a plus 1. Okay, so expand and simplify it to get a quadratic function. Okay, so what is the reason for the question asks you to find two possible values of a? Okay, so I'm sorry, I'm now figure there's 2, so means that your a has two answers. All right, so why does the question mention 2 a's? Because after you simplify this equation, you will get a quadratic function. Okay, after you solve for the quadratic function, okay, you may obtain the two final answers of a. All right, so you have 2a squared, 12a, and -54. All right, and divide 2 for all terms. So what will you get? You will get 27. Alright, so next you factorize it. A and A Okay, what is the product of 27? 9 times 7, right? Okay, 9. But it could be also 9 minus 3. Yeah, yeah. Okay, so we have positive 9 and negative 3 to get the sum of the roots of the positive 6. Okay, negative 6, then negative, negative, positive. Yeah. So negative 3 times 9, which is negative 27. Yeah, correct. Verified. Okay, divided into two cases. So we get a equals to 3 and negative 9. So these are the two possible values of a. Okay, that's the end of the discussion for this question. Alright, let's move on to the next question, which is the question 3. Okay, the point 2, negative 2, negative 3 is the midpoint of the line segment joining P, negative 6, negative 5, and QAB. Find the value of A and the value of B. Okay, so given that there's a straight line PQ, okay, so here is your P with the coordinate of negative 6, negative 5, as well as the Q, which is AB. Okay, so given that there's a point of negative 2, negative 3, which is about here, okay, so in common sense, P, this coordinate P and the point which lies between the line segment PQ, okay, they lie in the same quadrant, which is the negative quadrant. Alright, quadrant 3. So what should we do over here? Okay, so when it comes to it, this point is the midpoint of it. You need to use the formula of it. So to get negative 2, negative 3, this is the midpoint. Means that this length, this side, and this side are equal in length. Okay? So you can write the sum of the x coordinate, the average of the x coordinate, the average of sum of the x coordinate as well as the y. Okay, just did the same procedure. Okay, so here is the sum of the x coordinate divided by 2, sum of the y coordinate divided by 2. Okay, compare and find the values of a and b. So let me do it one by one. 2 times negative 2 is negative 4. Negative 4 plus 6, it's 2. So your answer is A. The answer of A should be 2. Meanwhile, for the y coordinates, just compare the y coordinates as well. Okay, negative 6 plus 5. So B is negative 1. Okay, so this is how you determine the values AB following the relationship of the midpoints. Okay, since this is the midpoint of between P and Q. Alright, so that's the end of the discussion for this question. Because this question is quite direct, so it shouldn't be difficult for you. Alright, let's move on to the next question, which is the question 4. Okay, three of the vertices of a parallelogram ABCD are A, negative 7, 3, B, negative 3, negative 11, and C, 3, negative 5. So for the part A, find the midpoint of AC. Okay, so yeah, I have drawn this diagram earlier for easier for me to visualize the patterns of the parallelogram inside this Cartesian plane. Okay, so in the common sense, D is in quadrant 2. Alright, in order to form a parallelogram for ABCD, each vertices. So now let's find the midpoint of AC. So midpoint of AC is just that simple. You just need to use the formula of the midpoint. Okay, actually we are looking for this point. So you just need to sum the x coordinate divided by 2 for x coordinate and did the same thing for y coordinate. Okay? Yeah, take this too. So I have -2, -1. Okay, the answer of the midpoint of AC is -2, -1. You may verify and see. So now let's move on to the part B. Okay, part B wants you to find the coordinates of D. Okay, remember that parallelogram is a quadrilateral, right? So every quadrilateral has two diagonals that has an intersection point, where this intersection point is the midpoint. Why? Because if you if you separate the midpoints, if you let the midpoints separate the each diagonals, this side and this side are equal in length, as well as another two sides of here. Okay, so therefore the midpoint of AC equals to the midpoint of the BD. Okay, where BD is another diagonal of this parallelogram. Okay, so I have -2, -1 that equals to, okay, refer to these two coordinates. So I have -3 plus A divided by 2, -11 plus B divided by 2 as well. Compare and find the values of A and B, and then rewrite the coordinates of D. Okay, so here you have -2, -1 as the midpoint of both diagonals that inscribed inside the parallelogram. So A, I have -1. Okay, this is not the final answer. So for B, I have 9. Okay, therefore your coordinates of the D is -1 and 9. Okay, that's all for the part B. Okay, let's move on to the final part for this question 4, part C. Okay, part C asks you to find the length of the diagonals AC and BD. So how to find the length distance between the two coordinates? You just need to use the distance formula that is derived from the Pythagoras theorem. Okay, so let's obtain the coordinates of A and C first in order to find the distance of AC. Okay, so I can label it as D AC, that denotes AC. Okay, you just need to take the square root of the square of -7 minus 3 square plus the square of 3 -5 square. Alright, you may use your calculator to calculate it, because the distance might be a square root form and also known as a irrational form of the answer. So in an exact form, you will get 2 square root of 41, or you can evaluate the decimal value as 12.8. Okay, because you need to put it as the 3 decimal places. Okay, it is best for you to put unit. And now let's find the another diagonals of BD. Okay, the distance of the diagonal BD. So first, you just need to carry out the same procedure as the previous one. Okay, so in the parallelogram, two diagonals. Alright, it doesn't matter for you to confirm whether diagonal AC and BD are equal in length. Let's just find out. So I have B, -3, -11, and the D is the result from the B you have done. Okay, carry out the distance formula. So I have in the exact form is 2 square root of 101, 101. In the decimal form, you will get 20.1 units square. Not square, because it is just only a distance. Okay, there you go. So you can verify by yourself and see the final answer of the distance of the diagonal AC is 12.8. Meanwhile, for distance of BD, you will get 20.1 unit. Alright, so I think that's the end of the questions. Alright, let's move on to the next question, which is the question 5. Okay, P is the point A minus 2, and Q is the point 4 minus 3A negative A. So are you curious? Are you curious why do I have to pronounce this slowly? Because for your understanding. Okay, so let me rephrase my sentence again. So basically the x coordinate of the P is A, y coordinate of P is A minus 2. For the Q, x coordinate is 4 minus 3A and the y coordinate is negative A. So hopefully you will understand what am I pronouncing about. Alright, so for the part A, find the gradient of the line PQ. So this first part should be easier, okay? So for the physics students, don't tell me you don't know what is gradient. Okay? This one you should learn from your secondary school. Alright? So what is the gradient of the PQ? It is just y minus 2 minus y1 x2 minus x1. Okay? Where this is your first coordinate, x1 y1 is the first coordinate, x2 y2 is your second coordinates. So just apply the gradient formula. For me, I will use a minus 2 minus a divided by a minus 4 minus 3a. Okay, so simplified for each numerator and denominator. So here I have 2a minus 2. Meanwhile, you have 4a minus 4. But that's not the end of it. Okay, because you haven't simplified it, instead you will see that there's a 2, 2, 4, and 4. So you will see that there's a common factor of a minus 1 after you factorize each numerator and denominator. So for the numerator, you can factorize as 2 a minus 1. Okay, for the 4, you factorize 4 times a minus 1. So as you can see that these two are common factors, cancel it out, as well as the 2 and 4. So eventually you will get half. Okay, 1 over 2 as the gradient of the PQ. Okay. Alright, let's move on to the part B. Okay, so I need to diminish this first. So for the part B, find the gradient of a line which is perpendicular to PQ. Okay, please emphasize this word perpendicular. What does it mean? You need to use the relationship of the two lines. Okay, so you will know that the line PQ is totally different with a line but perpendicular to PQ. So since your gradient of PQ is 1 over 2, which is positive gradient, okay, so let's say here is your gradient PQ, 1, 2, okay, and here is your perpendicular line. Let me label it as M2, over here 90 degree. So what is the relationship you need to use? You need to use the formula of it, which is the product of the two gradients MPQ times M, the perpendicular line, that equals to -1. Okay, use this formula and then you plug in the values. At least you will get the method marks. Alright, so MPQ is half. M2 we are looking for the answer we are looking for, and eventually your M2, the gradient of line perpendicular, is -2. Okay, so that's the answer for the B. Okay, let's move on to the C. Given that the distance PQ is 10 square root of 5, find the two possible values of A. Okay, so you need to use the information from the coordinates of P and Q and then use the distance formula and then equate to this value given and then to find the two possible values of A. So why does the question mention two possible values of A? Because the distance formula involves the quadratic equation after you square at the both sides. Okay, so let's carry out the workings without the nonsense. So I have the square root of A minus 4 minus 3A square plus A minus 2 minus A square, that equals to 10 square root of 5. So in my opinion, I have to simplify this term and this term first, just before I take the square at both sides. So for the first term, I have 4A minus 4 square. Meanwhile, I have 2A minus 2 square. And the next step is to take the square at both sides. So this square root and square may be cancelled. Okay, so using the indices rule, you need to multiply, you need to distribute this power 2 to the square root of 5 and the 10. Okay, so I have, after I square the 10 square root of 5, I have 100 times 5, which is 500. Okay, simultaneously, I can expand these two terms already. So I have 16A square negative 32A plus 16. For this, I have 4A square negative 8A and plus 4. Okay, so now you expand and simplify, you should obtain a quadratic equation. So I have 20A square negative 40, 20 minus 500, which is 480. Okay, so it is obviously divisible by 20 for each term. Okay, so divide 20 for all the terms. So I have A square minus 2A and negative 24. Okay, so now you need to solve the quadratic equation using whatever method. So for me, I will use factorization since its perfect square, its discriminant is a perfect square. So there are two possible values of A, which is 6 and negative 4. So yeah, that's the final answer for the part C, which is 6 and negative 4. Okay, that's all for this question. Okay, let's move on to the next question, which is the question 6. The diagram shows a rhombus ABCD over on the right hand side, where M is the midpoint of BD. Okay, so BD is a diagonal that inscribes inside the rhombus. Okay, because BD is one of the diagonal inside the rhombus. So for the part A, find the coordinates of M. How to find the coordinates of M? Okay, it is too easy for you to looking for M. Okay, so just use the midpoint formula. I'm not going to repeat this again. I just perform this working. So basically just sum of these two coordinates and divide by 2 for each x and y coordinates. So I have 6 and 6. Wow. What a coincidence. X and y coordinates are the same in magnitude. Alright, so that's the end of the part A. Okay, for part B, find the value of A, B, and C. Yeah, following the properties of the rhombus, rhombus is considered as a quadrilateral. So following the properties of the quadrilateral, okay, the midpoints of the two diagonals are the same. So you need to use the midpoint formula as well, just that the reverse process. Okay, since you know that the M is 6, 6, result from A, so I have to equate 6, 6 to A plus B over 2 for x coordinate, for y is 1 plus C divided by 2. Okay, so let's compare. Okay, so I have A plus B equals to 12. So I have two unknowns over here. That means I'm not able to obtain the value of A and B instantly. But for the another side, I can obtain the C short instantly. So C is 12. Okay. And here is your first equation. But how to find the values of A and B? Okay, so you have to aware that these two diagonals, they are perpendicular to each other. So means that you need to find the gradient of BD and gradient of AC. Take the product of them together is -1. Yeah, use this relationship in order to find the A and B. Okay, so for me, I will label it as equation 1. Okay, so what's the equation 2? It just basically simplified from this relationship to get the second equation, so that you can find the A and B already using these two simultaneous equations. So for the BD, I have 10 minus 2 and 4 minus 8 times what is AC. So A is, okay, you have obtained the C, which is 12. Okay, here is your 12 minus 1 divided by B, I don't know, as well as A. So two variables are unknown, which is B and A only. Okay, now expand and simplified, you should get another simultaneous linear equation. Okay, so I have 10 minus 2 divided by -4, So I have negative 2 for this, negative 2, so I have half over here. Here I have 12, I mean 11. Okay, so I have 22 equals to b minus a. So my a minus b is negative 22. So that's the second equation. Okay, so combine the first equation and the second equation, you will find the a already. So here I have 2a equals to negative 10. So what will be your a? The a you will get negative 5. Okay, that's the answer of the value of a. Okay, substitute your a equals to negative 5 into any equation. For me, I will substitute inside the equation 1. Okay, to make my job easier. So I have negative 5 plus b equals to 12. So what will be my value of b? Which is 17. Okay, so therefore, the value of a is negative 5, b 17, c 12. Okay, so before you obtain, there is a prompt before doing this part. Okay, so before finding the value of a, b, c, you need to predict the sign of the a, b, and c. Okay, so you see a is the x coordinate of a, so you need to predict that a should be a negative. A is confirmed the negative value, whereas bc is a positive values. Okay, so 4 is the x coordinate of d, as well as b is the x coordinate of c, so means that b must be greater than 4. Alright, and for the c, it is likely slightly greater than 10. Okay, so yeah, okay, this is the only prompt that I need to tell you before performing your workings for this kind of question. Okay, so I don't think I have enough space. I don't think I have sufficient space, so I need to create a new page. Okay, let's move on to the part C. Find the perimeter of the rhombus. So how to find the perimeter of rhombus? Okay, so following the properties of rhombus, each side are equal in length. Okay, this one you must memorize each properties of the quadrilaterals, alright, and as well as for the triangles. Okay, but for this case it is a quadrilateral. So all you have to do, how to find the perimeter of the rhombus, it's basically the 4 times of the side. Okay, because each sides are equal. Each side is equal. So I have to calculate the distance first. So for me, I will calculate the distance of AD, let's say. So now my A is negative 5, 1. So I can write negative 5, negative 4 square plus 1 minus 10 square. Okay? Press your calculator. You should get the perimeter of the rhombus. Okay, in the exact form, you will get 36 square root of 2, or in decimal, you can write it as 50.9 unit. Okay, that's all for this question. I mean for this part C. Okay, let's move on to the part D. Find the area of rhombus. So how to find the area of rhombus? You can directly use the shoelace formula to get the area of the rhombus. Okay, find the area by using the shoelace method. So let's start from A, which is negative 5, 1. Okay, B, 8, 2. C, BC is 17, 12. Okay, since B is 17. So C is 1712. D 410. Okay, finally back to the A, because you need to find the area of a closed rhombus. Okay, because polygon is always in the closed shape. Okay, perform your shoelace working to obtain the area of the rhombus. So I have 5 times -5 times 2, which is -10, 8 times 12, 96, 170, and 4. For the negative side, okay, which is the clockwise direction, I have 8, 17 times 2, 34, 12 times 4 is 48, and finally 50. Okay, so you need to find what is the value before it gets from modulus. So I have 220. So since 220 is a positive, so you just convert 220 modulus. So I have 110 as the final answer of the area of rhombus. Okay, so yeah, that's all for this question. Okay, let's move on to the next question, which is question 7. Okay, the perpendicular bisector of the line joining A -10, 5 and B -2, -1 intersects the x-axis at P and the y-axis at Q. Find the equation of the line PQ. Okay, so for the part A, for the coordinate P, when it intersects at the x-axis, means that the y-coordinate of the P must be 0. So let's label it as xp 0 for the coordinate of P. Meanwhile, for the Q, it intersects at y-axis, means that the x-coordinate of Q is 0. And let's label it as a 0 y-coordinate of the Q. Okay, you can make it in this way. Alright. Okay, so given that there's a line PQ intersects with AB by the midpoint of AB, because it says that the perpendicular bisector of the line, okay, the line refers to the line PQ. Okay, so bisector, okay, means that the perpendicular line which intersects midpoint with the original line. Okay, so first thing first, you need to find the midpoint of AB, which is -10 minus -2 divided by 2, and 5 minus plus, sorry, -10 plus minus -2 over 2, and 5 plus -1 divided by 2. So what will I get? I will get -6. Alright, and 5 minus 1, 4, I should get 2. Okay, meanwhile, the midpoint of, oh shit, okay, so after obtaining the midpoints, I need to find the gradient of the AB first. Okay, so what is the gradient of AB? Just using the gradient formula with 5 minus -1, -10, -2. So what is the gradient for AB? Which is -3/4. Okay, next you need to use the relationship by producting two gradients to get -1 because two lines, both lines are perpendicular to each other. Alright, so the product of their gradients is -1. Gradient AB is -3 or 4, and the gradient of PQ is, of course, if of the line PQ also intersects the midpoint AB. Okay, so I have y minus 2, x minus minus, instead I just write positive 6, -1. Okay, so in the next line I will put it as y minus 2 equals x plus y minus 2 over x plus 6 equals 4 over 3, since two negative are cancelled. Okay, so multiply, I don't need to multiply. Okay, as long I need to obtain an equation. So yeah, 4 over 3x 8. Okay, so what is this equation? Okay, so this equation is the equation of PQ. Okay, equation of PQ. So now it's time for you to find the wait a second. Oh yeah, correct. Actually, A asks you to find the equation of PQ, and there is. Okay, so I prefer to write in the gradient form. But if you want to write in the general form, is also acceptable. Okay, as long your equation is equivalent to the answer. Okay, following the marking scheme of the external examination past papers. Alright, so I need to diminish it first. Okay, so for part B, find the coordinates of P and Q. So as you know that the P lies on the y-axis. No, the P intersects at the x-axis. So means that the y coordinate of the P is 0, and I want to looking for x coordinate of P. So you can say that when y equals to 0, y equals to 0, x equals to x coordinate of P. So I have 0 over here, 4 over 3, x coordinate of P plus 10. So x coordinate of P is confirmed as negative. So the x coordinate of P is negative 15 over 2. So means that the coordinate of P is negative 15 over 2, 0. Okay, repeat the same thing for the Q, just that the Q intersects at y-axis, means that the x coordinate of the Q must be 0. So you can say that when x equals to 0, y equals to y cube. Okay, when y cube is a y coordinate of the Q, okay, so means that the y coordinate of Q is 10. So means that the coordinate of Q is 0, 10. That's all. Okay. Alright, let's move on to the section C. C, find the length of PQ. Okay, so since you obtain the coordinates of P and Q, so it's easier for you to find the length of PQ by using the distance formula. Okay, just press your calculator, see how much you get. So I will get 12.5, or you can put it as a fractional form, 25/2, also acceptable for these two equivalent terms for the answer. Okay, yeah, that's the end of the discussion for this question. Let's move on to the next question, which is the question 8. Okay, so this question involves the equation of the circle. Okay, find the equation of the circle that touches the x-axis, whose center is 6, -5. So remember the standard form of the equation of the circle, which is x minus p square plus y minus q square equals to r square. Okay, so where r is the radius and where the center is positive p and q, just take the p and q only from the negative. Okay, if you call x plus p square plus y plus q, so means that your center must be negative p and negative q. Okay, so for this question you don't need to do any calculations. Okay, so let's say here is your x-axis, okay, and here is your circle. Okay, because since this circle touches the x-axis at here, and let's say here is your center point, 6, -5. So you will see that this is a radius. Okay, so you will call that you will spot that the x-axis is tangent to the circle. Okay, where this is your radius. So you don't have to carry out any calculations to find the radius. So actually your radius is 5. Okay, because you will see that this radius line is perpendicular to the x-axis, and you will see that there's a -5. So there's 5 units away from the x-axis for the center of point vertically. So you will find the radius instantly. So what is the radius? The radius is 5. Okay, because radius can be only positive. All right, yeah, that makes sense. So to find the equation of circle, I just recommend you to write in the standard form, unless the question stated that you need to find the general form. Okay, so I have x following the standard form. I have x minus 6 square plus y minus -5 plus 5 equals to radius square. What is radius square? Okay, 5 square is 25. Okay, that's all for this question. Or in the alternative form, you can expand these two terms and then simplify into the standard form is also acceptable, as long your equation is equivalent to this standard form. Okay, that's all for this question. Okay, let's move on to the next question. Question 9. Question 9 also involves the equation of the circle. Okay, so given that the points P1, -2 and Q7, 1 lie on the circumference of a circle. Okay, so given that a circle, okay, and in the logical sense, I have 1, -2, which is about here. Okay, here is your P. 7, 1. 7, 1. So which is over here. Okay. Okay, so geometrically, these 2 points, this P and Q, apparently is not a straight line. Okay, but you will know that P and Q lie on the circumference of circle, That means you have a center here, okay, with a radius r. So what does it mean? It means that this distance is same as the distance of this. Or I can rephrase it as the distance QC equals to distance of PC, where C is the center of the circle. Okay, so you need to carry out the distance formula, okay, in order to find the center of the circle. Alright, so let me diminish it. Okay, this is easier for you to visualize and this is for your understanding. Okay, so assume C is xy. Okay, then so I have x minus 7 squared plus y minus 1 squared, that equals to x minus 1 squared plus y minus 2, y plus 2 squared. Okay, so cancel the square root at both sides. Okay, if you take the square at both sides, and I have the x squared minus 14x plus 49. Okay, and here you have y squared minus 2y plus 1 equals to x squared minus 2x plus 1, y squared plus 4y plus 4. Okay, and then cancel the x squared and the y squared at both sides, and then explain and simplify, see if you can get this equation or not. Okay, so for the x, I have negative 2 plus 14, okay, which I get 12x. And for the 4 plus 2, which is 6y. Okay, 49 plus 1, oh, okay, and also the plus 1 also can be cancelled. 49 minus 4, I should get wait a second, 49 minus 4, I should get 45. Okay, seems like I did any mistakes over here. Okay, let me recalculate it again. So negative 2 plus 14 is 12. Okay, and for the 4 plus 2 is 6. Okay, 7 times 7 is 49. 49 minus 4, I should get 45. Oh, I see. Maybe I can divide it. Maybe I was correct. Okay, so just divide by 3 at both sides of equations. So I have the 4x plus 2y equals 15. Yeah. So means that I don't need to find the center of circle, but just to know that the center of circle lies on the line 4x plus 2 equals to 15. Therefore, it's shown. Okay? Because using the equation of the locus of the distance formula, it is actually apparently to obtain the equation of the line which the center of circle lies in it. Okay, so yeah, that's the end of this question. Okay, let's proceed to the next question, which is the question 10. Okay, from this question on, this is the challenge question. Okay, so what is the challenge for this question? You just need to take one more step to obtain from this general form to the standard form. So how does it carry out? Okay, how to convert from the general form to standard form. Okay, so for now I will write this first. Okay, first step, group the x term on the left hand side, right term, y term, right hand side. Second, how to factorize into this square form. Okay, so remember, using the next step is to need to use the completing the square. Okay, just b over 2 bracket square. Okay, for each term. So for the x1 you have negative 6 over 2 square. Okay, for the y you have 2 over 2 square. Okay, meanwhile for the right hand side of the equation, you need to add negative 6 over 2 bracket square and 2 over 2 bracket square as well. Okay, so that you will factorize it easier. So for the x term, I will obtain x minus 3 square. Meanwhile, I have y plus 1 square. That equals to 6 plus 6 plus the another two terms, so I have 16. Okay, yeah, so here is the equation of the circle in the standard form. Okay, therefore shown. Alright, where a is 3, b is negative 1, and the r square is 16. Okay, hence write down the coordinates of the center of circle and also the radius circle. Okay, it should be easier. So given that you have 3 and negative 1, therefore the center of the circle is 3 negative 1, that's all. And you caught that the radius is just the square root of 16. I get 4. Okay, why it is not negative 4? Because radius is always positive. Okay, so yeah, that's the end of the question, end of the discussion for this question. Okay, let's move on to the next question, which is question 11. Okay, so from this question on, there will be a passive questions. Okay, for the rest of these questions. Okay, let's take a look at this question 11. So this is the passive questions of the 9709 May-June series 2003, question 7 from paper 1. Okay, the line L has equation 2x plus y equals to 8. The line L2 passes through the point A74 and is perpendicular to L1. For the first part, find the equation of L2. Okay, so highlight the keywords before answering the following questions. Okay, so how to find the equation of the line 2? So first of all, you need to obtain the gradient of the L2 first, just before you plug in the points. Okay, by using the gradient ratio and the relationships. Since the L2, okay, let's say, alright, for the L1, I have 2x plus y equals to 8. So I'm looking for the gradient. So apparently, the gradient of the L1 is negative 2, which is negative gradient. Okay, so Uh, okay, that means apparently your L2 must be a positive gradient. Okay, since the L1 and L2 is perpendicular. Alright, so you need to use the relationship of the gradient of L1 multiplied by the gradient of the L2 to get negative 1. Okay, your ML1 is negative 2 times ML2. Okay, that means the gradient of L2 is 1 over 2, which is half. Okay, next, what is another expression of the gradient of the L2? Okay, so that you have a 0.74. Okay, let's say here is your 74. Okay, and how do I gonna to know the gradient? Okay, let's say here is your xy. Okay, xy is the unknown variable in an linear equation. Okay, so I have to use another expression in terms of x and y to obtain the equation of the L2. So which I have y minus 4, okay, means the change of y and then the change of the x. Okay, fundamentally. So I have y minus 4 in the numerator. Meanwhile, in the denominator, I have x minus 7. Okay, and you may found it. So for this time, I will um, express in the form of this kind of form. Okay, same like this kind of form. Okay, and sorry about there's a misleading over here. Okay, apologize about that. So multiply, expand, and simplify. So I have x minus 2y equals to negative 1, or equivalent. Okay, what is the equivalent? Okay, if you give your another equivalent equation of in the gradient form, okay, it's also acceptable as long your equation in the gradient form must be equivalent to this one. Okay, according to the standard marking scheme of the pure mathematics one. All right, dealing with the coordinate geometry questions. So let's move on to the second part. Given that the lines L1 and L2 intersect at point B, and the question wants you to find the length of AB. So first thing first, you need to find the point B first, just before you find the length of the AB. So I have the line 1, I can label it as equation 1. Okay, and the line 2 is the equation that you obtain from the first part. That is your equation 2. Okay, so uh, for my method, I need to, let's say I want to get rid away one of the variable, which is y. What am I going to do? I can use the elimination method. So I have 1 times 2. Okay, so I get 4x plus 2y equals to 16. And here is my equation 3. Okay, so you'll spot that there's a plus 2y in the equation 3, and there's a negative 2y in equation 2. So what am I going to do is to combine the second equation with the third equation. This is not likely to combine, but we can rephrase my words as the sum. Okay, sum the two equations as 5x equals to 15. Yeah, because plus 2y plus negative 2y, actually they are cancelled out. And 16 minus 1, which is 15. Okay, so that means your x will be 3. Alright, so the 3 is the x coordinate of the B, point B. Okay, so Substitute the x equals to 3 into, let's say, equation 2. Okay, it doesn't matter if you substitute x equals to 3 inside this equation 1 or equation 3. Okay, in the end, you will get the same value of the y. Alright, so why do I have to substitute x equals to 3 into equation 2? It's because of it saves a lot of time to do other questions with the different chapters. Okay, so I'll discuss the past year questions once we finish all the syllabus from Pure Mathematics 1. Okay, stay tuned for my updates. So I have 3, okay, 2, 3 minus 2y equals negative 1. So what will be your y coordinate of the point B? With 2. Okay, so y, okay, now you will know, now you've known that your coordinate of B is 3, 2. And given that the coordinate of the A is 7, 4. Now, it makes your job easier to find the distance AB, just using the distance formula based on the Pythagoras theorem. Okay? So use your calculator to calculate it in case the final answer of the distance AB is not exact form. Okay, it is in rational form. So instead of writing the 2 square root of 5, I will write it as 4.47 unit. Apologize, the space is limited. Okay, so that's the final answer for the part 2, which is 4.47 unit. Okay, yeah, that's the end of the discussion for this question 11. Okay, let's move on to the next question, which is the question 12. This is also from the past year questions. So this is 9709 October November series 2005, question 7 from paper 1. Okay, 3 points have coordinates A 26, B 810, and C 60. The perpendicular bisector of AB meets the line BC at D. Find the equation of the perpendicular bisector of AB in the form of AX plus BY equals to C. So this is the requirement of the questions. Okay, so the examiners from the question wants you to leave your equation into the form, into this general form. So you have to obey it, because if candidates who do not obey the requirement of the questions, you will lose the mark. Yeah, the mark of the answer. Okay, accuracy mark. So take a look at the first part. Okay, so how to find the equation of perpendicular bisector? So first of all, this perpendicular bisector must in, because of the bisector refers to bi. What does the bi mean? The midpoint. Okay, means that each sides are equal. Okay, this perpendicular line that intersects with the line which is perpendicular each other. Okay, here is your B and here is your C. No matter where, it must be line between two sides are equal in length. Okay, so I hope you understand my explanation of the perpendicular bisector. So first of all, I need to find the midpoint of the AB first. Okay, just use the midpoint formula. I'm not going to explain this too much. Okay, to save the time to do the other questions. So midpoint AB is 5 and 8. Okay, so here I have 5, 8. And next I need to obtain the gradient of the AB, which is 10 minus 6, 8 minus 2. So that means AB has a positive gradient. Obviously, I have 2 over 3. Okay, let's assume the equation of perpendicular bisector is M2. Okay, so means that, I mean line 2. So means that the gradient of AB times the gradient of perpendicular bisector is -1. Okay, this is the relationship that you should know. Okay, so here you have 2 over 3 times m2 equals to -1. So that means your m2 is -3 over 2. Okay, so the perpendicular bisector still intersects with the 5, 8, the midpoint of uh, the midpoint of AB. Oh, sorry about that. Here is your AB. My mistake. Okay. All right. So I have to say y minus 8 and x minus 5. Okay, no matter any coordinates, move how much, the gradient is always -3 over 2. Okay, so the question wants you to live in this form. So I may multiply uh 2 multiply 2 and multiply the term x minus 5 at both sides of equations. So I have 2y -16 equals to -3x and +15. Okay, so I have the 3x plus 2y equals to uh 31. Okay, so let me check and see. Yeah, that's correct. Okay, the final answer of the equation of the perpendicular bisector of AB should be 3x minus 2y equals to 31. Okay, that's all for this question. And let's move on to the next part, which is part 2. Find the coordinates of D. Okay, so the perpendicular bisector AB meets the line BC at D. Herm. Okay. So first of all, you need to find uh, the gradient of the BC first. Okay, before obtaining the equation of BC. So I have 10 minus 0 and 8 minus 6. Okay, at the same time you can do the gradient ratio. Okay, so it is not necessary to always as the gradient of the 10 8. Instead you can replace 10 8 by x and y, so I can do it this way. All right, so 10 over 2, which is 5. So means that the equation BC should be 5 y equals to 5x minus 30. Okay, and if you want to change into the general form, so I should get 5x minus y equals to 30. Okay, here is your equation 1. And where is your equation 2? Your equation 2 is actually from the part 1 you obtained. Okay, and I may multiply the first equation by 2. So I have 10x minus 2y equals to 60. Okay, here is your equation 3. And now I combine the second equation and the third equation in order to get rid the variable y temporarily. Okay, in order to find x easier. So I have 13x equals to 91. Okay, what will be my x? My x is 7. Okay, because the question wants me to find the coordinates, so x equals to 7 is just the x coordinate of the point D. Alright, So substitute the x equals to 7 into the shortest equation, shortest possible. Among these three equations, you can only choose one to save your time. Alright, so I can substitute inside the first equation. Follow your opinion. Alright, so what will be my y coordinate of the point D? Which is 5. Okay, so your final answer of the coordinates of D, which is 7, 5. That's all. Okay, so yeah, that's the end of the discussion for this question. Alright, let's move on to the next question, which is the question 13. So this is the past year questions 9709 October November series 2006, question 5 from paper 1. Okay, so please look through the diagram. So from the diagram, there are 3 points A 13, B 13, 11, and C 6, 15 are shown in the diagram. The perpendicular from C to the straight line AB, which meets AB at the point D. Okay, so for the first part, find the equation of the CD. Alright, what are we going to do? As you can see that the line CD is perpendicular to line AB, so you should find how do you relate about the two lines which are perpendicular to each other. Okay, so you must use the relationship of their gradients. Okay, so first thing first, you need to looking for the gradient of AB. Okay, before leading to the equation of the CD, by looking for the gradients of CD first by using the relationship. Okay, so for the gradient of AB, you have to use the gradient formula, which is the difference in y coordinate and over the difference in x coordinate. Okay, so obviously the gradient for line AB is positive. Okay, so I have 2 over 3. Relate their gradients by using the relationship of the gradient of AB times the gradient of the CD equals -1, because two lines which are perpendicular to each other. Okay, so substitute the AB as 2 over 3 and then gradient of CD, and you should obtain gradient of CD easily. Alright, next you must find the gradient of CD but in terms of y and x, because equations of the CD, okay, a straight line equation only involve y and x variables. Okay, so let's assume a point which intersects with the line CD is xy. So the gradient of CD is equal to the gradient of C at this point. Okay, where this point can vary to any sides. Alright, so I have y minus 15 and x minus 6. Okay, so find the equation of the CD. Alright, so for this time I will express in the gradient form. So I have y equals to 3x negative 3 over 2x plus 24 as the final answer of the equation of CD. Alright, okay, let's move on to the second part. Find the coordinates of D. Okay, so first thing first, you have this equation resulted from the first part. So now you have to find the equation of the AB. Okay, by right, the equation of the AB is easily to be found. So given that the gradient of AB is 2 over 3, okay, that you have evaluated from the part 1. Okay, now Now I have to state y minus 1, y minus 3, x minus 1. Okay, because you take the gradients with any point, any 2 points, which intersects as long it intersects inside the AB. Okay, so let's say here is your xy, where this xy intersects in the line AB only. Okay, so I have y minus, that's why I have y minus 3 x over x minus 1. Okay, so now you need to um, expand and simplify into the simultaneous form, I mean the general form. Okay, so I have 2x minus 3y equals to -7. Okay, here is your equation 1. So this equation 1 refers to the equation of the AB. Meanwhile, you have another equation that is resulted from A. Okay, so that's your equation 2. Alright, so to get rid away the variable y, so I can substitute the second equation into the first equation. Okay, to find the x first before finding the y. Alright, so just use your calculator to calculate the values of x first. So by right, your answer for the x is, wait, I need to recalculate again. So I have -7 plus 24 times 3, which is 65, divided by 2 plus 9 over 2. Okay, the answer of x, which is 10. Alright. Okay, substitute the x equals to 10 into second equation. Okay, to make my job easier. So what's the value of y? I get 9. Okay, so the question asks you to write find the coordinates of D. So you have to rewrite the coordinate of D as 10, 9. Okay, that's the final answer. So yeah, okay, we have done this question already. Alright, let's move on to the next question, which is the question 14. So this is the past year questions 9709 October November series 2007, question 6 from paper 1. Okay, 3 points A 38, B 62, and C 102 are shown in the diagram. The coordinates of point D is unknown. The point D is such that the line DA is perpendicular to AB and DC, where DC is parallel to AB. Calculate the coordinates of D. Alright, so when it comes to the relationship of perpendicular and parallel, so first thing we need to look forward to parallel first. Okay, so the most important thing for this question, we have to find the gradients first. Okay, before relating their gradients by using these two informations. Okay, so the gradient AB, which is 8 minus 2 over 3 minus 6, it is obviously a negative gradient for the line AB. Okay, because its slope goes downwards. Okay, so I have -2 for the gradient of AB. So it says that DC is parallel to AB. What does it mean? It means that okay, where DC is parallel to AB means that their gradients are the same. Therefore, the gradient of AB equals to the gradient of DC. Okay? or I have to move a bit above a bit. Okay, so means that the gradient of the DC is -2. Okay, and now it's time for me to form an equation of the DC. All right, so how to relate the DC? Okay, where the coordinates D is unknown, so you can only write it as let the D coordinates of D become x, y. Okay, and assume assume the coordinates of D is x, y. Okay, where x, y that we want to find, we want to looking for these two values before stating the coordinates of D as your final answer. So you have to relate the gradient in terms of x and y minus 2 over x minus 10. Okay, so when it comes to solving for coordinates, I not recommend you to leave your equation as a gradient form because it's quite troublesome for you to solve the simultaneous equation. Okay, it is still able to solve for the coordinates of the center point, but it takes you a lot of time. All right, so okay, maybe I continue my workings in the next space. So I have y minus 2 equals negative 2x plus 20. Alright, so I have 2x plus y equals 22 as my equation 1. So now I have successfully obtained the equation of DC. And now I want to obtain the equation of AD right now. Alright, so see the another information. Line DA is perpendicular to AB. It means that, okay, when DA is perpendicular to AB, it means that the the line DA is perpendicular to line AB, means that the gradient of the DA multiplied by the gradient of the AB is -1. Alright, so what is the gradient of AB, which is -2? Okay, and the gradient of DA is half. Okay, so always remember when there's a line which is perpendicular to another line, the sign of the gradient of another line is always opposite to its line. Okay, remember about that. Just that you need to uh, memorize the relationship in terms of gradients. All right. Okay, so now I have obtained the gradient of dA. Select any point. Assume the coordinate of D is x, y. So you need to relate the gradient of dA in terms of y and x. Okay, so I have 2y minus 16, x minus 3. Okay, I have x minus 2y, um, negative 16 plus 3, which is negative 13. So this is as your second equation. Okay, now I have first equation and the second equation. Now it's time for me to solve it. So from equation, maybe this time I will using substitution method. Okay, from the 2, x equals to 2y minus 13 as my equation 3. Okay, alright, substitute equation 3 into the equation 1. So what I have is to get rid one of the variables before finding the another variables. Okay, so now solve for your y. So for the y value, I have, you can leave it as decimal 9.6 or 48 over 5. Okay, and yeah, for the accurate ones, to remain it exact, I may leave it, for me, I may leave it as a fraction. Okay, alright, so in the final step, you have to substitute 48 over 5, y equals to 48 over 5 into equation 3 to looking for your x. Okay, so my the final answer of the x is 31 over 5. Okay, therefore the coordinates of d is 31 over 5, 48 over 5. Okay, you can leave it as fraction. Okay, this is the most recommended for you to leave the answer in the fraction form and also exact form, or you can leave it as decimal form. Okay, it is optional, no restriction. Okay, as long the answer of coordinates is equivalent as the mark scheme stated. Alright, so that's the end of the discussion for this question. Okay, let's move on to the next question, which is question 15. Although this is the last passing question since the equation of circle does not exist in the older syllabus, but I will provide the extra questions for the equation of circles later. So this is the passing questions of the 9709 May June 2008, question 11, paper 1. Okay, in the diagram, the points A and C lie on the x and y axis respectively. Okay, so you may see this diagram. Assume this diagram is accurate and you must trust it. The equation of AC is 2y plus x equals 16. The point B has coordinates 2, 2. The perpendicular from B to AC that meets the AC at the point X. Alright, so for the first part, find the coordinates of X. So what should we do? First thing first, we want to looking for the gradient of AC. Okay, so you must solve two simultaneous equations to get the coordinates of x, right? So first thing first, you need to looking for the gradient of AC. Okay, that means you don't have to looking for the two coordinates of to find the gradient. Instead, you can as you can change this general form into the gradient form. So let's move it. Okay, here is the gradient form y equals to mx plus c form, which is y equals to negative half x plus 8. Alright, so means that from this gradient form equation of AC, the gradient of AC is negative half. Okay, so we have introduced the line bx, so we can relate that the gradient of bx times the gradient of the AC is negative 1 since the bx is perpendicular to AC. Okay, so the gradient of bx remains and the AC is negative half. So the gradient of bx is 2, positive 2. Okay, so as I said, assume the coordinates of x is unknown, label it as xy, and then express the gradient of this with only a known coordinates, okay, in terms of x and y. That leads to another equation of the bx. Alright, so I have y minus 2 x minus 2. Okay, So for the equation just now, we can label it as equation 1. Okay, why do I have to change to this gradient form? In order to find gradient easily. Alright, so now for this, multiply x minus 2 at both sides. So I have 2x minus 4. Okay, so I have 2x minus y equals 2 as your equation 2. Okay, so now it's time for us to solve the simultaneous equation. Okay, so I can say from 2 y equals 2x minus 2. Okay, here is your equation 3. Substitute the equation 3 into the equation 1. So I have this. Okay, to get rid away one of the variable. Alright. So the x you obtain should be 4. Okay. Next, substitute x equals to 4 into third equation. So I have 6. Okay, means that the coordinates of x is 4, 6. Alright. Okay, so from I know you were confused that the coordinates of x. So it is actually meaning to find one of the coordinates of x in this certain range diagram. Okay, so you don't have to worry about there are how many coordinates of x. Okay, because a linear graphs only intersects to another linear graphs only at one point because their gradients are constants. Okay, so let's take a look. Let's move on to the next part. The point D is such that the quadrilateral ABCD has AC as a line of symmetry. Find the coordinates of D. Okay, so what should we do over here? We have one of the triangle, right? So it means that we have another triangle. Okay, so let me draw it. So it means that the coordinates of D is the reflection of the coordinate of the point B through this line. Okay, so let me draw a line. So as you can see that you can form a kite. Okay, so kite is also considered as the quadrilateral because it says that the AC as a line of symmetry. Alright, so let's label here as D. Okay, so what does it mean? It means that the distance of BX and XD are the same. So you have to find the distance of the BX first. Okay, so how to find the distance of BX? By using the distance formula from the Pythagoras theorem. Okay, so I have 4 minus 2 square plus 6 minus 2 square. So what I have is I have 2 square root of 5 remain inexact because as this is just only a part to lead to the answer of the coordinates of D. Okay, so therefore I'm sorry, this is BX, my mistake. So it means that the distance of DX is also 2, 5. just that we don't know what's the coordinate of the D, right? So instead, we can express the distance dx in the form in terms of x and y, correct? So as you can see that if you're using the distance formula, you will form a equation of the circle, right? So I have, let's say here is a point D. Sorry, it's point X. So I have x minus 4 square and y minus 6 square. So as you can see that in the end you have to multiply, take the square at the both side. So I have square root of 20. Okay, cancel at the both side and expand this one. So I have x square minus 8x plus 16, y square minus 12y plus 36 equals 20. So I have x square plus y square minus 8x minus 12y, okay, and plus 32 equals to 0 as equation 1. Okay, and of course you have the equation of the bx already, which is also the equation of the bd since the gradients are the same. Okay, so you will have 2x minus y equals 2 as equation 2. Now it's time for you to solve for the x and y. Okay. Okay, so from equation 2, y equals to 2x minus 2, equation 3. Substitute your equation 3 into equation 1. X square plus 2x minus 2 square minus 8x minus 12, 2x minus 2 plus 32. Okay, as you can see that you will form a quadratic equation. So expand and simplify now. Okay, so I need to create a new page to have sufficient space for me to complete each part in these questions. Okay, you can divide all the quadratic terms, all the terms in the quadratic equation by 5. Okay, because each term has a common term which is 5. And factorize because it seems to be factorizable. Alright, so the two possibles of x can be 2 or 6, but it depends on the condition from the diagram. Okay, so what can you predict that? As you know that the coordinates of the x is 4, 6, so means that the x coordinate of d must greater than 4. And also the coordinates of the y coordinates of d must greater than 6. Okay, but we are looking for the coordinates of the x first, the x coordinate of the point D. So means that the x coordinate of the D must greater than 4. So as you can see that only 6 is greater than 4. For another case, which x equals to 2 is rejected because the x coordinate of the 2 is actually for the point B. So when you see there's a distance formula, actually you are forming the equation of the circle where B and D intersects the circumference. Okay? Where the radius is the distance of the BX. So it is easier for you to find the y coordinates of the point D. So let's substitute the x equals to 6 into the third equation. Y equals to 2 times 6 minus 2, which is 10. Okay? So hence the coordinate of D is 6, 10. Okay? Makes sense. Okay, makes sense from the diagram. The x coordinate and y coordinate of D must greater than x and B. Alright. So let's proceed to the third part. Find correct to one decimal place the perimeter of ABCD. So we have found that the ABCD is a kite. Okay? Generally it is a quadrilateral for the ABCD. So how to find the perimeter of the ABCD? Okay? So following the properties of the quadrilaterals, there must be two sides which equal in length. Okay? Meanwhile, the another two sides must equal in length as well. Alright? So what are you going to do? You can use a shortcut or tricks to find the perimeter of the quadrilateral ABCD. We can do it in this way, which is 2 times of the perimeter. Maybe I write it as P. The perimeter, the distance of the BC and the distance of AB. Okay? So when it comes to the requirement for the questions, you need to obey this one. Okay, you must give the final answer in one decimal place for the perimeter of the ABCD. Okay, so let me indicate again. This side and this side are equal in length, as well as this side and this side must equal in length each other. Okay, so let's carry out the distance formula. So what is the distance of the BC? Obtain two coordinates and use the distance formula. Okay, but I'm not able to find the coordinates of C. Actually, it is determinable because when you derive from general form of the equation into the gradient form, you can see there's a y-intercept of 8, means that the coordinate of C must be 0, 8. Alright, that's not a trick, but this is the basic concept of the equation of the straight line, which is y equals to mx plus c gradient form. So I have the square root of 2 minus 0. Maybe I have to write the coordinates first. So I need to recall that I have to find the coordinates of A as well. Okay, so when y equals to 0, what will be your x? Must be positive, right? Okay, so when y equals to 0, what will be your x? Okay, the x is 16. So it means that the coordinate of A is 16, 0. Alright, now I have coordinates of A, I have coordinates of B, and coordinates of C, which is 0, 8. Yeah. Okay. 2 minus zeros. Okay. Plus 2 minus 8 square. Take the square root for the distance BC. Take the square root of 16 minus 2 square and 0 minus 2 square. Close the bracket. So now you need to, the best way is to press your own calculator in one shot to obtain the decimal value of the perimeter of ABCD. Okay, so I have the twice of the square root of the 2 minus 0 square, 2 minus 8, which is 6 square, okay, which is 36, 16 minus 2 square, minus 2 square, I will have 40 over 9 units. Okay, it's best for you to leave your answer for the perimeter area in the units or unit square. Okay, so that's the answer when you are dealing with the geometry questions. Okay, so if you have any hesitation, please reach out to me. Alright, don't be shy. Alright, I think that's the end of the discussion for this question, and it is also the last partial questions in the exercise of chapter 3. Alright. Alright, let's move on to the question 16. So question 16 is the extra questions for the equation of circle because equation of circle does not exist in the older syllabus. Okay, so let's take a look at this question. A circle has equation of this particular equations. Alright, for the first part, state the coordinates of center of this circle and its radius. Alright, so don't confuse about the coordinates. Okay, center of a circle only has a particular center point only, so you have to state only one. Okay, so let me copy the equations over here. Okay, so using the standard form, this is the concept for the equation of circle. Okay, you must state that the center of the circle, let's say O, is 3, 2 generally. Okay, and what's the radius from this particular circle? It is the square root of this number because following the standard form of the equation of circle. Okay, so just take the square root of 25. That means your radius is 5. Okay, so that's all for this part. Let's move on to the second part. Verify that the point A with coordinates 6, -6 lies on this circle. Show also that the point B on the circle for which AB is a diameter and B has coordinates of 0, 2. Okay, so let's solve the first part first before the second part. So basically you just have to let your y, x equals 6 and y equals -6, just carry out the substitution enough. Okay, so it is clearly evident that the point A lies on the circumference of the circle. So let it become left hand side and right hand side. Okay, left hand side of the equation and right hand side of the equation. Okay, right hand side of the equation is 25. Assume it this way. Okay, substitute your x and y coordinates from the point A inside this left hand side of the equation. So use your calculator. By right, you should get the same numerical values with the right hand side. So you can conclude that the left hand side equals to the right hand side. Therefore, you have successfully verified that the point A lies on the circumference of this circle. right? So for the next part, how to show that the point B also lies on the circumference of the circle for which AB is a diameter. Okay, so there are many ways to carry out the workings. Okay, so first thing first, you can say when x equals 0, y equals 2. Okay, you can carry out the same way as the above one. So you have 0 minus 3 square plus 2 plus 2 square. Okay, and the right hand side is 25. Okay, 9 plus 16 is also 25. Okay, so is it the end of this workings to show that the B and B lies on the circumference of circle for which the AB is a diameter? Of course, it isn't an end, because this working only clearly evidence that B lies on the circumference. Okay, there's not even enough evidence to, you haven't proved that AB is a diameter. Okay, so this can only clearly evident that B lies on the circle. Okay, I mean the circumference of circle. So yeah, okay, let's move on to the next proof. So how to know that AB is a diameter? Second, you can carry out the distance formula by looking for the distance of the AB. Okay, so as you know that the radius is 5 from the first part, so why not you may carry out the distance by using the distance formula. Alright, there you go. So after you calculate the distance of AB, you should get 10. So what will we see? Okay, it's basically the twice of the radius. Alright, since the radius is 5, okay, 10 is the product of 2 times 5, means that the distance AB, okay, you can say distance AB is the twice of the radius, means that AB is a diameter. So therefore, shown as well as here, shown as well. Okay? But we can also prove that AOB is a straight line or collinear. So there is an alternative proof, alternative workings to prove that AOB is diameter and three coordinates are collinear to each other. So you may carry out the area of the AOB by using the shoelace method. Okay, just find the area of polygon using the shoelace method. So what is the coordinates of A? Of A is 6, negative 6. What is the center? 3, negative 2. What is B? B is 0, 2. And all the way back to 6, negative 6. So using the shoelace method, cross multiply like that in the addition and carry out the same way for the negative side. So you have negative 12 plus 6 minus 18 plus 12. Yeah. Okay, so in the end, you evaluate this as half of the modulus of 0. So means that Therefore, the area of AOB is 0 unit square. Okay, what does it mean? It means that AOB is when AOB connects and AOB connect together, they will form a straight line, okay, for which point AOB are collinears, okay, is a straight line and collinear to each other. This one, I think some of you should learn this from your secondary school, okay, so therefore it's also shown. Okay, so you don't have to carry out much more steps, because if you carry out many unnecessary workings, it takes you a lot of time to complete this just an ordinary questions. Okay, although this question seems to be like difficult, but it's actually very simple and neat. Okay, so let's move on to the third part. Okay, find the equation of the tangent to the circle at A. Okay, so what is the center point? 3, -2. So, in my opinion, I have to draw a diagram for your understanding. Here is your 3, -2. So what would be your positions of the point A, 6, -6, which is positive quadrant over here. Okay? So here is your approximate position of the coordinates of A. Okay? So point A obviously lies at the fourth quadrant because positive x and negative y. Okay, I want to looking for the equation of the tangent. Yeah, this tangent line. Can you see it? Okay. Next, you draw a straight line. So always remember that for for a circle, a tangent, a tangent, a tangent line which intersects to the circle only one point, where the tangent line is always perpendicular to the radius. So that means here you have a right angle. Okay? So how to find the equation of tangent is just that simple. How to relate between, assume this radius is the equation of the line and equation of tangent is another equation, another line. So how can we relate these two lines? Okay, we can use the gradients to relate them using the in terms of gradients. Okay, so means that the gradient of the radius times the gradient of the tangent equals -1. Use this relationship. So first thing first, let's say here is your O, okay, the gradient of OA, or you can say gradient of radius, which is using the gradient formula -2, -6 over 3 minus 6. So the gradient of radius is obviously negative gradient. Okay? Obviously has a negative gradient. So I have -4 over 3. Okay? Next, it's time for you to use the relationship over here, this one, which is -4 over 3 times the gradient of tangent equals -1. So the gradient of tangent is 3 over 4. Okay, now replace your gradient of tangent only in terms of x and y, since you have only one known point which intersects with the equation of with the tangent. So let's label any point who intersects the equation of tangent as x and y. Alright, so I have y minus -6 over x minus 6. Okay, so I have y plus 6 equals 3 over 4x minus 9 over 2. Okay, eventually you have y equals to 3 over 4 plus 3 over 2. That's the answer of the equation of tangents. Got it? Okay? So it's just that simple. By relating the radius with the tangent to the circle. Okay? So let's take a look at the last part for this question. Fourth part. Okay. There's a sudden appear of a second circle who touches the original circle at A. Okay? Its radius is 10 and its center is at C, where BAC is a straight line. Find the coordinates of C and hence write down the equation of second circle. Okay. So there is a prompt from this question. So from the information of the questions, the radius of a second circle is 10. However, I don't know the center of the circle, C. Okay? So the first task for this part is to find the center of the circle. Let's label it as PQ. Alright? So generally I have x minus p square plus y minus q square equals 10 square. Okay, using the standard form of the equation of circle, but this is the second particular circle. Okay. So, yeah. Okay, let's copy down this graph. Now I have the second circle. So let's say here is the point A. Okay. And I want to looking for the center of the circle. So geometrically, the center of circle for P and Q must be both. I mean for the P must be greater than 6 and Q must be less than negative 6. So this is the best prediction or prompt before looking for the center of the circle, the coordinates of center of the second circle. Okay? So it tells you that the BAC is a straight line. Okay, means that the gradient of the BA equals to the gradient of the AC. Okay, this is the best prompt to relate it. Okay, so I want to substitute away the x and y. Okay, what I have, that is, given that the point A intersects with the second circle and the first circle simultaneously, so you must let when x equals 6, y equals negative 6, so what I have is 6 minus p square minus 6 minus q square equals 100. Okay, since 10 square is 100, this one I will use it later. So expand and simplify into the general form of the equation of circle. So I have p square minus 12p plus 36 q square plus 12q plus 36 equals 100. So I have p square plus q square minus 12p plus 12q minus 28, equals 0. So this is as my first equation. Next, I may use the relationship as I mentioned just now. The gradient of BA equals to gradient of AC since they are collinear to each other. Okay? They refers to the coordinates of B, O, A, and C. Okay? So I may find the gradient of BA first numerically. So I have actually basically the gradient of BA is exactly same as the gradient of the radius, which is -4/3. You don't have to carry out the extra workings over here, okay, as it might take you a lot of time, okay. So what is the gradient of AC, but only in terms of P and Q, okay. So I can have -6 negative Q minus Q over 6 minus P, okay. Now expand and simplify into a linear equation, but only in terms of P and Q. Alright, so as you can see that the negative can be cancelled if you factorize the numerator out with the negative and cancel at both sides. Okay, so I have 24 minus 4p equals 18 plus 3p. What I have is 4p plus 3p equals to 6. That is your equation 2. Okay? Uh-oh, I don't have enough space. Okay? And now you have two simultaneous equations, but one is linear, one is the likely quadratic. But the quadratic must be only have one term, but one variable, but this equation has two variables. Therefore, I need to get rid away one of the variables uh, in order to find one of the variables. Okay. So how to get rid away one of the variable? So from equation 2, I need to let's say I want to let the Q. Okay. It is optional if you can follow your opinions to solve the two simultaneous equations. So I let the Q equals to 6 minus 4p overall over 3 as my equation 3. Okay. And then next you substitute your third equation into the first equation. Okay. So I have p squared plus 6 minus 4p over 3 squared minus 12p plus 12, 6 minus 4p over 3 minus 28 equals 0. Okay, now it's time for, now expand and simplify. By right, you should get a quadratic equation. Okay, but only in terms of p. So I have p squared plus 9, 16p squared. Okay, negative 48p plus 36 minus 12p, and okay, multiply 3 at both sides. So I have 9, okay, 12 times 3 times 6, so I have 206. 12 times 3 times 4, I have 144p minus 28. Okay, why do I have to satisfy the denominator with over here? Okay, because to multiply all the denominators factor easily, okay, for the convenience for me to solve the quadratic equation. So let's multiply 9 at all terms. So I have 9p squared plus 16p squared minus 48p plus 36 minus 108p plus 216 minus 144p minus 252. Okay, so I have 25p squared negative 300p. Okay, So this is what I have. And now, you see, 25 is a factor of 5, right? Therefore, 300 is also a factor of 5. Okay, means that if you divide 300 by 25, it is divisible. 300 is divisible by 25, so you may factorize 25p outside. Okay, so there's no constant, it makes your job easier. Okay, so I have p minus 12. Okay, so what will be your answer for the p? Okay, you can separate into two cases, so you will get p equals 0 or p equals 12. But from the condition, from the boundaries above that I have set, p must be greater than 6, so means that only p equals to 12 is a sensible value. Okay, where 0 doesn't make sense. So you have to reject p equals 0. And now substitute p equals 12 into equation 3 to looking for the value of q. So remember, the q must be less than -6. The q is -14. Okay, now I have successfully found p, the value of both values of p and q. So we are able to write what is the coordinate of c. Okay, so therefore the coordinates of the center c for the second equation is 12, -14. And let's rewrite the equation, the exact equation of the second circle, which is x minus 12 square plus y plus 14 square equals to 100. That's all for this question. Okay? Okay, let's move on to the last questions among the exercises of chapter 3, and this is also the last question for the extra exercise for the equation of circle. Okay, a circle has equation of this particular equation. For the first part, state the coordinates of center and the radius of a circle. Okay, for the first part, basically this is the same type of the question from the previous one. Okay, so you have to follow the standard form of the equation of circle. Okay, just state that the center of circle, let's say O, okay, I mean C this time, is 5, 2. Okay, that's all. And what about the radius of the circle? It's just square root of this numerical value from the standard form of the equation of circle. So I have to take the square root of 20, which is 2 square root of 5. Okay, I'm encouraging you to leave your answer of the radius in the exact form. Okay, instead of leaving it as a decimal value. Okay, so that's the answer of the center of circle and the radius. Okay, let's move on to the second part. State with a reason whether or not this circle intersects y-axis. Okay, so we have to pay attention to the keyword of the intersects the y-axis. What does it mean? Okay, when, let's say the graph is the equation of circle, I mean the circle which intersects the y-axis means that its x coordinate is 0. So you have to say when x equals 0, okay, substitute x equals to 0 inside the equation of circle, and by right you should form a quadratic equation. Excuse me. Okay, there you go. And move the 25 to the other side. So we have y minus 2 bracket square equals -5. Until here, what will you observe that as the square function is always positive for x subsets to all real numbers. Okay, provided that the y minus 2 is always real numbers, means that its bracket square must be always positive. So it is impossible to make this value negative. So you can say that as y minus 2 bracket square is always positive, the circle does not intersect the x-axis. I'm sorry, the y-axis. Okay, so that's the answer, which is simple and neat. Instead, there's an alternative solutions that you can do. Okay, some of you will say, okay, just expand this equation and move the 5 to the other side to form a quadratic equation. Then you can use the discriminant to verify that the discriminant is negative, to evidence that the circle does not intersect the y-axis. Is it acceptable? Yes, of course. Okay, following the mark scheme from the examiner. Okay, so let's continue the steps by using the expand and simplify into the quadratic equation in the general form. So I have y squared minus 4y plus 4 equals negative 5. So I have y squared minus 4y plus 9. Okay, apply the discriminant formula, looking for the discriminant. What is the polarity of the discriminant? Okay, so I have negative 4 squared. Okay, so it is negative. Okay, so you can say that since b squared minus 4ac less than 0, there is no real solution. Okay, for this quadratic equation. Therefore, the circle does not intersect the y-axis. That's all about it. Okay, that's all for this part. So I think so far, what types of candidates you answer when you're dealing with this part 2. Okay, so these two methods is what I expect, okay, for the candidates to answer this part of the questions. So let's move on to the third part. Find the equation of the line which is parallel to the line y equals to 2x that passes through the center of the circle. Okay, there is a circle, correct? And let's say here is the center point, phi 2. Y equals to 2x. Okay, let's say here is a y equals to 2x, right? And there's another line that is recognized. It means that, let's say here is the first line, and here is the second line. It says that it mentions that the line 1 and line 2 are parallel to each other. So what does it mean? When line 1 is parallel to line 2, you have to relate their gradients. Okay? Therefore, their gradients are the same. M1 equals to M2. Because they have same inclinations. Okay? Same slope. I mean the same magnitude of the slopeness. Okay? So means that the gradient of first line is 2 as well. Okay? And you have to replace the gradient of the first line in terms of x and y in order to form the equation of this line that passes through the center. Okay? Means that phi 2 as the center of circle intersects with the first line. Okay, so I have y minus 2 over x minus 5. So what I can get? You will get 2x, y equals to 2x minus 8 as your final answer. Okay? Alright, let's move on to the last part of this question. Show that the line y equals to 2x plus 2 is a tangent to the circle. Okay, hence state the coordinates of the point of contact. Okay, so now you have new introduced a tangent line. Okay, so let's say here is the tangent line. Okay, always remember that whenever there is a tangent line that intersects with a curve, it only has exactly one point of contact when there's a tangent line which intersects with the curve. Okay, equation of circle is considered as a curve. Circle is considered as the curvature of the circle. Okay, so I have the equation x minus 5 bracket square plus y minus 2 bracket square equals to 20 as your first equation, and given there's a tangent to the curve, y equals to 2x plus 2. So you label it as equation 2. Okay, and now substitute the equation 2 into the equation 1. Okay, because now we have to first show that the line, this line is tangent to the circle, means that this line only intersects with the circle at one common point only, exactly. Alright, so I have x minus 5 square. What is the y? Which is 2x plus 2. Plus 2 minus 2, it's 0. So I can have x squared. X squared minus, this one can cancel, minus 10x plus 25. Okay, and if you square only 2x, you will get 4x squared equals 20. Okay, 5x negative 10x plus 5. So as you can see that 5 is the common factor for each term in this quadratic equation. So I can express it as x squared minus 2x plus 1. So it is a perfect square. You can factorize it easier. So I have x minus 1 square. Oh, wait. I haven't proved that this line is tangent to the curve, to the circle. So I may use the discriminant to verify that this line is a tangent to the circle. So let's carry out the discriminant. 2 square minus 4, b square minus 4ac. This is okay, which is 0. Okay. So yeah, it's shown. Okay, you have to write the statement over here. So means that y equals to x plus 2 is tangent to the circle because of it intersects exactly one point with the circle. Okay, so that's the end of the proving that the line, this is the tangent to the circle. So now hence we want to looking for the point of the contact. Okay, what does the point of contact meaning? The intersection point between the tangent line with the circle. Okay, so there's only one point of contact. So next you solve this equation by using the factorization. So I have x minus 1 square. My x is 1. Okay, substitute x equals to 1 into equation 2. Okay, because I want to save my time. You have to save your time by using this strategy. So the y is 4. Okay, that means eventually the point of contact is 1, 4. That's all for this question. Okay, so yeah, I think I have not I think. Okay, that's the end of the discussion for the exercises for chapter 3. Okay, thank you. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.